The good part about this worksheet is that it's just a matter in each problem of taking the information there and plugging it into one of these many equations. So what should we go through first? 6, 4. We'll start with 4 then. So number 4, Michelangelo is riding his turtle bike at 10 meters per second toward a stationary police car whose siren is emitting a frequency of 588 hertz. What frequency does Mikey hear? So we've got a stationary police car in this situation. So we're not going to be using any of these 4 equations for this problem because both of them are not moving, just one is. So we've got a stationary observer or sound source, and it's moving toward. So that means we're going to be doing one of these approaching equations, and it's asking for frequency. So this is the equation we're going to be looking at right there, because we have a stationary observer and the objects are getting closer. So what is the frequency that Mikey hears? We just have to plug in the appropriate numbers into this equation. So let's see what it gives us. The emitted frequency is 588. So 588 goes in for this F. 588 goes there. What is the speed of sound? 343, that's right, listed on the top of that worksheet. So these two numbers here are 343. And what is that velocity going to be? 10. Yeah, right on the money. So when you plug all those numbers in, you should end up with a frequency of 606 hertz. 606. So that's number 4. Number 10? 2. Yeah, let's take a look at number 2. So number 2, we've got Shredder, and he's holding 2 vibrating tuning forks. Be an interesting picture of Shredder holding 2 tuning forks. One produces a wave 1.21 meters long, and the other produces a wave 1.24 meters long. How are we going to get the beat frequency out of this? That's the question. So we've got 2 wavelengths, but we don't have any frequencies. So somehow we got to turn those wavelengths into frequencies, and in order to do that, we got to use this equation way down here. Wave speed equals wavelength times frequency. I've also talked about how you can write it like this. So if we want to find frequencies, we need speed and we need wavelength. And we actually have both of those things. Wave speed, again, speed of sound is 343. And wavelength is given to us in this problem. We've got 2 of them there. So frequency 1 is going to be wave speed 343 divided by the wavelength they give us, which is 1.21. Frequency 2 is, again, the wave speed divided by the other wavelength they give us, 1.24. And when you get those numbers, you should end up with 283 hertz for one, and 277 for the other. Questions on where any of these numbers came from? From here, it's just a matter of subtracting. Beat frequency is the difference between the two. So 283 minus 277 gets you a beat frequency of 6 hertz. There's a little bit of rounding in there too, because I rounded these to 3 digits. So if you got a beat frequency of 5 or 7 or something, that's acceptable. All right, so that one's number 2. Then number 6, I heard. This one's an interesting one. Now we've got the technodrome. You guys know what the technodrome is? No? Okay. Brush up on your Ninja Turtle history and you'll find it. It's this gigantic, like, big sphere. It's kind of like the Death Star, I guess, but cooler. And it goes on these like tank wheels, and it rolls through the underground until finally it tries to come up onto the surface of the Earth. So, at least that's what it did in the old cartoon. But, so that's the Technodrome. Krang is inside this. He's that little brain evil guy. And he hears the frequency of the wings of a bee at 245 hertz. So that is the observed frequency. That's what he hears. Now, when the bee's moving through that's when he's moving through the air. If the bee is hovering, just holding still, not moving anywhere, the frequency is 251. So 245 is the observed frequency. It's what Krang hears. 251 would be the actual produced frequency is. So question 1, is it flying toward or away from Krang? So when it's holding still, it's 251. When he hears it, it's 245. Is it flying toward or away from him? Well, it's actually going to be flying away from him. Because when objects are moving away from you, the pitch and the frequency goes down. Like when the fire truck went by in the video we watched, and the siren all of a sudden got really low pitch, low frequency. That frequency went down. So in this case, too, if we see that frequency drop from 251 to 245, that means that that fly is moving away from Krang. So then what is the bee's speed? So Krang's holding still, which is nice. So we're going to use one of these. We're looking for speed, so that's one of these too. And if it's moving away from him, this is leaving. That means this is the equation we have to use right there. So it's just a matter of plugging those values in again. So remember, F with the apostrophe is the observed frequency. It's what he hears. And he observes a frequency of 245. So 245 goes right there. F is the frequency that's actually emitted. That's what you would hear if it was holding still, just hovering. And that's 251. So 251 goes up there. Vs is the speed of sound. Of course, that's still 343. So when you plug those numbers in, you should get a velocity of 8.4 meters per second. That is how quick that fly is traveling inside the Technodrome. This one down here is the observed frequency. That's 245. Other questions from the worksheet? Nothing from the backside? I know we at least got to go through number 8. Sure. We'll take care of number 8 one step at a time here. Yeah. Sure. Let's look at 7A. So the foot soldier is holding still. So immediately we know we're going to be using one of these equations up here because we have a stationary observer. And we're looking for wavelength. Well, that's interesting. In order to get wavelength, we're going to need wave speed and frequency. We need these two things. Again, that equation's down here again, too. So if we can get a frequency and a wave speed, then we can get that wavelength. Wave speed's still 343, but if we want to get a frequency, that's something we have to use these equations for. So we're going to either use this equation or we're going to use this one. Should I use left or right? Yeah. We got to use this guy because that train is going towards the foot soldier. So let's see here. For this equation, the observed frequency is this guy all the way on the left. That's what we're looking for. Now, the frequency that's emitted is 600 hertz. So that F right here is 600. Vs, once again, is speed of sound. So 343 goes in for both of those velocities.
What number is
This
this?
is number 7A. And then finally, that velocity right there is given to us as 15 meters per second. This is how fast that train's moving. So when you plug all those numbers in, you're going to get a frequency of 627 hertz. So now we know this is 343 as always. This is 627. And so you can use this equation then to solve for your wavelength. 343 divided by 627, and you should end up with 0.547 meters. That's your wavelength for this question. The trick is just being able to realize that to get wavelength, you need both of those. And hopefully that pushes you in the direction of solving for that frequency. Questions on that one? All right, let's take a look at number 8 then. The biggest part of number 8 is making sure we know what's happening here. So we'll read through number 8 nice and slowly, and then we'll do what we need to do. So, Donatello wants to test the Doppler effect, and he devises an experiment. I got my Donatello purple on today. Leonardo plays a bugle while standing in the back of the turtle van moving toward a pizzeria. So Leonardo is playing a bugle, and he's the one that's moving, and he's moving towards something. Splinter is standing at the pizzeria playing his bugle. So we've got two people playing bugles. We've got Master Splinter holding still at the pizzeria. We've got Leonardo playing it as he's approaching the pizzeria. So they're both playing a 512 hertz note. Donnie, standing in the middle, hears 5 beats per second. How fast is the turtle van going? Now, that's a lot of information, and it's a lot of words. We need to cut through that to what's important. Number 1, we've got a stationary observer. Donnie's holding still. So we're going to be using one of these equations up here. And he's approaching, so we're going to use one of these two. We're looking for velocity, so this here is the equation, ultimately, that we need to deal with. So from this equation, let's see what we know. We know the speed of sound. This number here is 343, as is this number right there. So now we've got the two frequencies that are left over. So each are playing a 512 hertz note. So this is the actual frequency that's being produced. This is not the frequency that Donnie's hearing. They're both doing this frequency from their bugle. That is the F up here. The frequency that Donnie's going to hear, which is going to be different, is going to go down here. Now the thing is, it doesn't actually tell us what frequency Donnie's hearing. All we know is that he hears a beat frequency of 5 beats per second. So, stay with me now. 512 hertz is the note that's being produced. Leo is going towards Donnie. So is Donnie going to hear 5 hertz more than this or 5 hertz less than this? More, because he's going towards Donatello, which means your frequency, your pitch is going to be higher. So that means the observed frequency is 517 hertz. 517 hertz then goes right here. Let's go through that reasoning one more time. We know that 512 hertz is the frequency of the note that's being produced. If you were holding still, if both Leo and Splinter were holding still, this is what you would hear from both of their bugles. But Leo's going towards Donnie. And Donnie hears 5 beats per second. That's the beat frequency. So that means the frequency that Donnie actually hears is going to be 5 plus this, or 5, or this minus 5. And because Leo is moving towards Donnie, that means that frequency is going to be the higher of the two, because that's what happens because of the Doppler effect. Ergo, 517 goes right there. And when you plug all the rest of those numbers in, you'll get a velocity of 3.32 meters per second. 3.32. Yes?
What are those top numbers?
So, Vs, that's 343.
Okay.
This observed one here is 517.
That's on the bottom.
Yep. And then the top F is the 512. That's the frequency that's just emitted.
Oh, okay.
Yep.
What's the answer again?
Answer is 3.32 meters per second. So, on your way out, put this worksheet in the second tray down on the right side. Review day tomorrow. See you then.